with S3 objects. An object in Amazon S3 consists of both object data and metadata. The object's metadata is made up of key value pairs that provide additional information about the object. There are two types of metadata, system-defined and user-defined. System-defined metadata is information that S3 maintains. This data includes information such as creation date and object size. User-defined metadata is data you can assign to an object. The metadata must start with the x-amz-meta prefix. Say that you want to tag each object with its owner. You could create a user-defined metadata tag of x-amz-meta-owner. You could then use this tag to track the owner information. Next, you'll learn how to load an object into an S3 bucket. The put operation is used to load objects programmatically into Amazon S3. You must have write permissions on the bucket and you'll receive a success response after the object is written. Remember that when you write an object to S3, the entire object is written as a whole. It doesn't just write the changes. This is an important consideration when you need to write large objects. Speaking of large objects, you can't put objects that are larger than 5 gigabytes. For larger objects, use the multi-part upload, which splits a single object into a set of parts. If transmission of any part fails, you can resume that upload without affecting the other parts. After all parts of your object are uploaded, S3 assembles these parts and creates the object. Although you must use multi-part upload for objects larger than 5 gigabytes, a general recommendation is to use it for objects larger than 100 megabytes. Multi-part upload improves throughput, and it can also resume failed uploads. This slide shows example code that invokes the put operation. First, the code imports the SDK for Python. Next, it instantiates a client service object for the Amazon S3 service and specifies that it will be working in the US East 1 region. Next, the code creates a variable to hold the bucket name it's going to use, and then it specifies the object. This is an example of what you learned about object prefixes. Then the code has the upload operation itself. The client calls the upload_file operation with arguments for the file name, bucket name, and object key. This key is the destination file name. And for the final arguments, it specifies the file type as text and the max age value as 0. That setting stops client browsers from caching the object locally. After an object is uploaded to Amazon S3, use the get operation to retrieve it. Using get requires read access to the bucket. You can retrieve a complete object or only parts of an object by specifying a range of bytes. This capability is useful when you need to download large objects over slow or inconsistent connections. Thanks for watching and see you in the next video. Welcome back. We'll continue section 4, part 2 by discussing how to select objects in Amazon S3. You can use the select operation to query S3 objects based on structured query language or SQL. S3 uses this format to parse object data into records, and it returns records that match the specified SQL expression. Say that you're a data analyst for a retail store chain, and you work with files formatted as comma-separated values, or CSV. You need to analyze sales data from a particular store, but the CSV file with that store's data also includes data from 300 other stores. Without the select operation in S3, you need to download the file and then process the entire file to get the data for one store. By using the select operation, you can use a simple SQL expression to return only the data you need instead of the whole object. Versioning in Amazon S3 means that it keeps multiple variants of an object in the same bucket. When you enable S3 versioning, you can create solutions that give users access to every version of an object. Because it stores multiple versions, you can recover from an unintended object deletion. By default, versioning is disabled in S3 buckets. After enabling it, you can suspend it, but not disable it. When you suspend versioning, S3 keeps all versions of the objects that were in the bucket. Amazon S3 Object Lock is another option that you can use to prevent data from being changed, overwritten, or deleted. So, what happens if you delete an Amazon S3 object when versioning is disabled? In an S3 bucket that isn't versioned, a delete operation permanently deletes the object. You can supply the object key value, and S3 removes the object. In the example, the delete object operation is called with the key value of jazz.mp3. The object is then removed from S3 storage, leaving an empty bucket. In a bucket with versioning enabled, the delete operation works differently. In a versioned bucket, the delete operation inserts a delete marker for that object into the bucket. The object hasn't been removed, but the delete marker causes get operations for the object to result in an HTTP 404 message, which is object not found. What if you want to delete a specific version of an object? Call the delete operation with the object's key value and the version ID. From this slide, you can see that the jazz.mp3 file has multiple variants. Each version has an associated version ID. When an initial delete operation is run against the file, the delete marker is added, and it becomes the current version of the file. After that point, any get operations will result in the HTTP 404 response or file not found. When the version ID is specified, the delete operation is applied to a specific variant of the file. In this case, version 2222222 is deleted, and only one file variant is kept in the bucket. Here are the key takeaways from this section of the module. Objects in S3 buckets have two types of metadata: system-defined and user-defined. Amazon S3 has three operations: put, get, and delete. S3 Select is a powerful tool to query data in place. And S3 bucket versioning protects objects. Thanks for watching. I'll see you in the next video.
Welcome to Module 4, Securing Access to Cloud Resources. Section 1, Introduction. At the end of this module, you should be able to describe the AWS Shared Responsibility Model, explain how AWS Identity and Access Management, or IAM, helps secure access to AWS resources, describe IAM user authentication, and identify how to authorize access to AWS services by using IAM users, groups, and roles. This module will cover the shared responsibility model and introduce the IAM service. This module will also cover authenticating with IAM and authorizing with IAM. Frank and Martha liked the proof of concept website, and now other team members are going to help Sophia to develop the cafe's web application. Before development continues, she decides to define the level of access that users and systems should have across cloud resources. With IAM, Sophia can define roles to give to other team members based on what they will build, maintain, or access. For example, she might create a developer role and a database administrator role. Sophia will use IAM to clearly define what level of access each user should have to the AWS resources that the cafe website uses. That's it for this video. Thanks for watching, and see you in the next video. Section 2, Shared Responsibility Model. Ensuring security and compliance is a shared responsibility between AWS and the customer. It's important to differentiate who is responsible for what. Thus, it's helpful to summarize that AWS is responsible for security of the cloud, but the customer is responsible for security in the cloud. Actual customer responsibilities are determined by the AWS cloud services that a customer uses. However, customers are generally responsible for managing their data. Customers are also responsible for using IAM and other security services or features to configure the appropriate implementation-specific security. With the shared responsibility model, AWS provides security of the cloud's physical infrastructure, which the customer might have previously managed. As a result, the customer's operational burden is reduced. In addition, the nature of this shared responsibility also provides the customer with flexibility and control, which helps them to build custom applications and make practical use of cloud computing resources. AWS operates, manages, and controls security of the cloud. The customer assumes responsibility and management in the cloud. In this activity, we'll look at the specific components of this shared responsibility. You will classify security responsibilities by whether they are the responsibility of AWS or the customer. Let's get started. First, who is responsible for the security of regions? That's right, AWS is responsible for regions. Who is responsible for security of customer data? That's right, the customer is responsible for customer data. Who is responsible for security of operating system, network, and firewall configuration? That's right, the customer is responsible for security of operating system, network, and firewall configuration. Who is responsible for security of storage? That's right, AWS is responsible for security of storage. Who is responsible for security of hardware and AWS global infrastructure? That's right, AWS is responsible for hardware and AWS global infrastructure. Who is responsible for security of client-side data encryption and data integrity authentication? That's right, the customer is responsible for client-side data encryption and data integrity and authentication. Who is responsible for security of networking traffic protection, including encryption, integrity, and identity? That's right, the customer is responsible for networking traffic protection, including encryption, integrity, and identity. Who is responsible for security of availability zones? That's right, AWS is responsible for availability zones. Who is responsible for security of networking? That's right, AWS is responsible for networking. Who is responsible for security of software? That's right, AWS is responsible for software. Who is responsible for security of edge locations? That's right, AWS is responsible for edge locations. Who is responsible for security of server-side encryption, meaning the file system and data? That's right, the customer is responsible for server-side encryption, meaning the file system and data. Who is responsible for security of compute? That's right, AWS is responsible for compute. Who is responsible for security of platform, applications, identity, and access management? That's right, the customer is responsible for platform, applications, and identity and access management. Who is responsible for security of databases? That's right, AWS is responsible for databases. In this example, say that you work for a company and use Amazon Simple Storage Service, also called Amazon S3, to store some of your company's data. You also created an Amazon Elastic Compute Cloud, or Amazon EC2, instance, and an Amazon Relational Database Service, known as Amazon RDS, instance. These instances run a MySQL database that's deployed inside a virtual private cloud, known as a VPC. The EC2 instance hosts a web server, and the web application that runs on it uses the database to store application data. In this scenario, AWS is responsible for protecting the global infrastructure, which contains the physical servers that host the virtual machines and storage hardware. These virtual machines and storage hardware host your S3 bucket, EC2 instances, and database instance. AWS is responsible for the security of the physical networking infrastructure that ensures these components can be accessed. AWS is also responsible for the security of the hypervisor layer that hosts the EC2 instances. The hypervisor is the host OS that runs the EC2 instances, which are virtual machines that run guest OSs. The customer is responsible for managing the guest OS that runs on the EC2 instances, including Microsoft Windows or Linux OS updates and security patches. They're also responsible for managing any application software or utilities that you install. Additionally, they're responsible for the configuration of the security groups that control network access to each EC2 instance and the RDS database instance. The company is also responsible for configuring security on the S3 bucket and the objects you store in it. For example, they could use one or more security features that AWS provides, such as bucket policies, data encryption, and S3 block public access. That's it for this video. Thanks for watching, and see you in the next video. Section 3, Introducing AWS Identity and Access Management. AWS Identity and Access Management is also known as IAM. With this service, you can configure fine-grained access control to AWS resources. You can follow security best practices by granting unique security credentials to roles, users, and groups. These credentials specify which AWS APIs and resources these users can access. Users have no access to AWS resources until permissions are explicitly granted. IAM is integrated into most AWS services. You can define access controls from one place in the AWS Management Console, and they take effect throughout your AWS environment. You can use IAM to grant employees and applications access to the console and to AWS Service APIs by using existing identity systems. AWS supports federation from corporate systems such as Microsoft Active Directory and standards-based identity providers. IAM also supports multi-factor authentication, also known as MFA. If MFA is enabled, the user is prompted for an authentication code when logging in. The authentication code is delivered to an AWS MFA device, which might be a hardware device. Virtual MFA devices are also available, such as an application that runs on the user's smartphone, for example, Google Authenticator. With IAM, you can control who can use your AWS resources. This component is the identity or authentication. You can also control what resources they can use and in what ways. This component is the access management or authorization. To understand the fundamental aspects of authentication and authorization, consider a banking analogy. Think of a bank that provides online banking. Suppose that you are a bank customer. You have money in a checking account at that bank, and you want to pay a bill online. Should any random person be able to log into your bank account and pay their bills with the money in your account? Of course not. Before the bank allows you to access your checking account, it must ensure that the person accessing the account is actually you. The bank wants to authenticate that you are who you claim to be. The bank accomplishes this by requiring you to enter your username and a password that is known only to you. For extra security, they might have two-factor authentication, meaning that you receive a code on your phone and must enter that code. Now, suppose that you are successfully logged in, authenticated to the bank website. Can you pay your bill by using the money in some other customer's account? No, you shouldn't be able to. You don't have the authorization to access accounts that don't belong to you. However, you are authorized to access money in your account, and you are authorized to pay bills with your money. how does this analogy relate to IAM? Similar to how a bank must secure access to your money, you, as an AWS account owner, must secure access to your AWS account. You want whatever data that you store in your account to be secure so that others can't access it. Likewise, you want to secure the application logic of anything that you build on AWS so that others can't modify it. IAM provides many features that can help you to accomplish these security objectives. You can use IAM to control access to your AWS resources. To achieve this, create users, groups, and roles in IAM. You can also enforce access control by attaching policies. An IAM user is an entity that you create in AWS to represent a person or application that interacts with AWS account services and resources. A user is given a permanent set of credentials which stay with the user until a forced rotation occurs. An IAM group is a collection of IAM users. You can use groups to grant the same set of permissions to multiple users. An IAM role is similar to a user. However, a role doesn't have long-term credentials, such as a password or access keys. Instead, when a person or application assumes a role, they receive temporary security credentials for the session. An IAM policy is a document that explicitly lists permissions. You can attach a policy to an IAM user, IAM group, IAM role, or any combination of these resources. To configure long-term access, a best practice is to attach IAM policies to IAM groups, and then assign IAM users to these IAM groups. An IAM user in an IAM group inherits the permissions attached to that group. You can also attach IAM policies directly to an IAM user to further customize access. That's it for this video. Thanks for watching, and see you in the next video. Let's review the module and wrap up with a practice certification exam question. In summary, in this module, you learned how to describe the AWS shared responsibility model, explain how IAM helps secure access to AWS resources, describe IAM user authentication, and identify how to authorize access to AWS services by using IAM users, groups, and roles. Now let's take a look at a sample exam question. A company is storing an access key, which includes an access key ID and secret access key, in a text file on a custom Amazon machine image, or AMI. The company uses the access key to access DynamoDB tables from instances that are created from the AMI. The security team has mandated a more secure solution. Which solution will meet the security team's mandate? A, put the access key in an S3 bucket and retrieve the access key on boot from the instance. B, pass the access key to the instance through instance user data. C, obtain the access key from a key server that is launched in a private subnet. D, create an IAM role with permissions to access the table and launch all instances with the new role. Note the key requirements stated in the problem. The solution needs to store an access key on a custom AMI to provide access to DynamoDB tables, and it must be more secure than what they are currently using. Consider the answer choices and rule them out based on these key requirements. We'll pause for a few seconds before discussing the correct answer. If you need more time to consider the answer choices, you can pause the video. So how do these answer choices compare to the requirements? Put the access key in an S3 bucket and retrieve the access key on boot from the instance. This involves the creation of an access key, which introduces the complexity of managing that secret. So that's not going to meet the security requirements. Pass the access key to the instances through instance user data. This again involves the creation of an access key, which introduces the complexity of managing that secret. So that's also not going to meet the requirements. Obtain the access key from a key server that is launched in a private subnet. This also involves the creation of an access key, which introduces the complexity of managing that secret. So that's also not going to meet the requirements. Create an IAM role with permissions to access the table and launch all instances with the new role. That could be the answer. The correct answer must be D. An IAM role for an EC2 instance allows applications that run on the instance to access AWS resources without needing to create and store any access keys. Remember that any solution that involves the creation of an access key also introduces the complexity of managing that secret. Thanks for watching. We'll see you again in the next video.
Welcome to Module 5, Developing Flexible NoSQL Solutions. We'll begin with Section 1, Introduction. At the end of this module, you should be able to recognize different database options on AWS, identify the features of Amazon DynamoDB, describe the components of DynamoDB, explain how Amazon DynamoDB uses partitions, and indicate how indexes are used with DynamoDB. You should also be able to describe how DynamoDB keeps data consistent, recognize when streaming and global tables are used, explain the backup and restore process, and develop with DynamoDB by using the AWS SDKs. In this module, you will learn about AWS database options, key concepts for DynamoDB, partitions and data distribution, and secondary indexes. You will also learn about read-write throughput, streams and global tables, backup and restore, and basic operations for DynamoDB tables. The cafe has a basic website now. Sophia wants to modify the site so that information can be updated dynamically and staff members can retrieve information about the product inventory. Sophia decides to store this information in DynamoDB database. As a proof of concept, she decides to create a script that retrieves all inventory items from the table, and another script that retrieves a single record from a product name. This diagram gives an overview of the application you will build through the labs in this course. The highlighted portions are relevant to this module. As highlighted in the diagram, you will set up a DynamoDB database to store the product information. That's it for this video. Thanks for watching. See you in the next video.